Okay. Right. Okay. Right. Good evening. I hope I'm audible. Let me share the live to the channels and groups. Okay. Right. Okay, it's audible. Right. We'll share these two channels and then start. You can find the questions through the video description, or you can find the same from this pinned message here, not comment, pinned message here in live chat. Right. You also can share if there's anyone who's who is in need of joining this. Right. Today we'll be discussing the rest of elasticity questions. Right. If there's anyone who is in need of this, feel free to share. That's fine. Okay. Right. Then we'll start. I have shared the live in the channels and groups. And if you haven't downloaded the questions yet, or if you don't have the questions with you, right, these are the past paper questions now. So probably you might have the questions with you, but if not, if you don't have the questions with you, you can get the questions from this pin message I have pinned here in live chat or in the description of the video, right? Let me share my screen. Right, let's start. Right. Okay then. Visible, right? Screen is visible, right? Okay. All right. Let's start. The last day we have discussed 18 questions, and today I'm starting from the 19th one onwards, right? Today starting from the 19 onwards. Okay. 19. Let's see. A metal block is hung from a support by a string P. An identical piece of string Q is attached underneath the block. Consider the following statements. Right. If a Q is taut, the tension in P is greater than that of Q. Tension in P is greater than that of Q. Right. So about tensions, this is how we can get an idea. This is how we can get an idea about tensions. Right. Now let's say tension of this one is TQ. Right. And this same tension remains here up to here. But this is a mass that is hung here. Then this weight is also here because of that mass. Then with the impact of TQ and mg, TQ plus mg, right? TQ plus mg, if this is TP, right? Tension at P is higher, right? Just by looking at these forces, we can say TP equals TQ plus mg. Tp equals Tq plus mg. So that is greater than Tq. That's a correct statement. That is greater than Tq. Then the first one is, if Q is taut, the tension in P is greater than that of Q. Yes, tension of P is greater because Tp is Tq plus something, Tq plus mg. Tq plus mg. Right? B. If Q is pulled with slowly increasing tension, then P has tendency to break down before Q. Now, we have already found that Tp is greater than Tq, no? Right? Q has a higher tension, right? Higher tension means P is reaching the maximum tensile stress or the maximum stress first. It has a higher force compared to Q. It has a higher tension. It has a higher tension compared to Q. Higher tension means higher stress, right? So higher the stress, faster it reaches the maximum stress or the tensile stress, right? So this is correct. See, if Q is pulled with a jerk, then Q has tendency to break down. Q has tendency to break down before P. If Q is pulled with a jerk, then Q has a tendency to break down before P. Right? Jerk means, listen, jerk means now it is going to apply a force in a very less time, within a very less time. Then impulse and impulsive forces occur. Impulsive force. So because of the impact of impulsive force, there's a probability of breaking from Q. Right? There's a probability of breaking from Q. Right? So this is also correct. That is because of the impulse. For 19, it's 5. Right? Now, jerk means this is about impulse. Jerk, that is about impulse. Right? Okay. Let's move on. Next, 20. A steel, Young's modulus E, linear expansivity alpha. Beam of cross-sectional area A is clamped between two concrete supports. When the temperature of the beam rises by delta T, the force that must be exerted by the concrete supports to each end of the beam in order to keep the beam without expanding is given by. Right. So this is a proved equation in the class. Right. This is a proved equation in the theory class. Right. So as an equation, this is F over A equals Y alpha theta. Right. So at once we can use this if a temperature difference is given. If a temperature difference is given, we can use this at once. Right. If there's anyone who don't know the equation, this is how this equation is derived. F over A equals Y E over L, no? Using thermal expansion, we know, right? Using thermal expansion, we all know that delta L can be written as L1 alpha theta. Delta L is an extension, no? So that is an extension. Then plug this value here. Plug this here for this E. Then F over A equals Y. E is initial length L alpha theta over initial length L. These two cancels. Then F over A equals Y alpha theta. Right. So these are proved equation. If a temperature difference is given, at once we can apply. Right. If a temperature difference is given, we can apply at once. Then force is asked. So force is given by Y A alpha theta. Plug these values. For Y, E is given. Right. A is given. Alpha is given as alpha, and temperature difference is given as delta T. So that is EA alpha delta T. EA alpha delta T, that is 1. Right? So if you knew the equation, there's nothing to do in the question, right? The answer is only one step away. If you knew the equation, but if you didn't know the equation, sometimes you might have to get confused, and sometimes you might like trying to prove this somehow. But keep this in mind. If a temperature difference is given, we have only this equation. If the temperature difference is given, right? 21. A water tank is constructed on a steel pillar of original length L0 and water is filled up to a height h is as shown in figure, right? The variation of the compression delta L of the pillar from original length with the height of what level is best represented by? Right, okay. First thing, there are two forces acting here. One is weight of water. One is weight of water. Right? Say this is simple mg, and there's another one that is weight of pillar mg. Right? Now, if we apply our equation, F of A equals y E of L, right? Total force is simple M plus capital Mg over A y E of L, right? Total force. But we know this is the water mass, then M can be expanded as V rho. V can be written as AH, then AH rho. V rho can be written as AH rho, right? Then if I expand this, this is simple M is AH rho, no? AH rho plus capital M G over A y, instead of E delta L is given L over initial length L, right? Now delta L should be subjected because that is going to be my y variable. To subject delta L, right, you can simplify the brackets. See, now delta L equals this is AH rho plus M, right, over A y, and here G L, right? Now we can see the shape, right? But if you didn't see, simplify the bracket now. Simplify the bracket if you didn't see the shape. Delta L equals, right? Here A to A cancels, then rho GL over Y times H remains, plus from here capital MGL over AY remains, right? Right. And this is see, this is my X variable. Then this whole part should be gradient. This is my Y variable, right? And here it should be, this should be our intercept. So that is mx plus c. That is mx plus c. Answer 2. Mx plus c. Right? Given graph is mx plus c. Right? Mx plus c. Mx plus c. Right. Next. 22. A and B are two iron columns with exactly the same length. Right. Then say L and L, same length. A has a square cross section of side length A. Right. Then a square cross section of side length A. Side length A, which means cross sectional area is A squared, no? If the side length is A. Right. So this is A and this should be B. While B has a circular cross section of diameter A. Diameter A. Here the diameter is A. When diameter is A, what about area? Right, we know area is pi r squared, diameter is A, then A over 2 whole thing squared, no? Pi r squared. Then this area is pi A squared over 4. मैंने आ गया एरिया आएगा pi A squared over 4. Right? One end of A and B is firmly fixed on horizontal ground. An ununiform concrete beam is placed over the two columns as shown in the figure. If the lower side of the concrete beam remains horizontal, the distance x2, center of gravity of the beam, from axis A is given by, right, A is very less than L. Okay, then if it remains horizontal, we know always extension should be equal. If it remains horizontal, extensions should be equal. Then E equals E, right? We can write extension as FL over Y, you know, because we know F over A equals Y E over L. Then from here, extension is FL over YA. FL over YA. Use it here, right? Then A, this is like extension of A equals extension of B, right? Then here, force. Let's mark these reactions. Let's mark this reaction on A as RA. and reaction on B as RB. Reactions are RA and RB. Then EA. EA is RAL over same Y, right? Same Y, 2 ion columns, right? And area A squared. For RB same length, same Y, but area is YA squared of 4, right? Y to Y cancels. Then L to L cancels. A squared to A squared cancels, right? Then cross multiply this and simplify. Then it gives 5RA equals 4RB. Let's keep this relationship. We'll need to use this somewhere when we take force movements, because without taking force movements, you can't find the distance, no? Right? Now, I'm going to write force movements about this point G. We can write force movements about point G. We can write the force movement about point G. Right? Then considering the equilibrium, force movements about point G. Right? Considering the equilibrium. Leftward force moment is by RB. Right? If this is X, this part has to be L minus X. So that is L minus X. And clockwise is by RA, distance is X. Right? To remove RA and RB, I have a relationship here. Then I'm going to plug RB. RB is 5RA of 4. Then RB is 5RA of 4. L minus X. This is RA X. Now RA to RX, RA to RA cancels. Now this is 5 times L minus X equals 4x. Simplify the bracket. 5L minus 5x equals 4x. Then 5L equals, take x out, 5 plus 4. Right? Then we need x. X equals 5L over 5 plus 4. 5L over 5 plus 4, it's 5. Right? That's a good one. That's a good one. Right? Followed by a little bit a tricky calculation. Right? A little bit tricky calculation. Right? Next. 23. 23. Two light rods of initial length L1 and L2 having equal areas of cross section, right? Equal areas of cross section are joined end to end. A force F is applied as shown, right? So in series combination, we know always force is equal. So if this force is F, throughout this rod also that is F, throughout this rod also that is same, that is F, right? If the respective Young's modulus of the material of rods are E1 and E2, they will contract by the same amount when they will contract by the same amount, right? Again, that is about contractions, same contractions, which means extensions are equal, right? Again, E1 equals E2, right? We know E can be written as FL over YA, right? Same thing again, because F over A equals Y times E over L. Extension is given by the equation as FL over YA. Extension is given as FL over YA. Then use it here. L is L1, Y is E1A, same area, it says same F, L2, E2A. Then A to A cancels, F2, F cancels, cross multiply. Then L1, E2 equals L2, E1, right? L1, E2 equals L2, E1. The answers are given as E2, L1 equals E1, L2, right? E2, L1 equals E1, L2. 1 second. Okay, so what's it then? E2, L1 equals E1, L2. E2, L1, E1, L2 can 1, it's 1. Right? So that's an easy calculation. That's an easy calculation. Right? No much logic. Logic right? Equal contractions, right? So consider equal contractions when contractions are equal. FLOYA, right? So apply it and just simplify. That's it. That's not a big deal. That's not a big deal. Right? Next. 24. The figure shows an iron wire fastened to a brass frame. At room temperature, the wire is neither slack nor under stress. The linear expansivity of brass and iron are, right, linear expansivities of these two are given 18 times 10 to the power minus 6 and 10 times 10 to the power minus 6, respectively. Young's modulus of iron is 12 times 10 to the power 9. When the temperature of the whole system is increased by 1 degree Celsius, the stress on wire will become. Okay. Now, the thing is, when the temperature increases, both brass and iron extends, no? Both extends, right? Now, the thing is this, they have two linear expansivities. Now, extension of brass is, say, EB, right? We know from thermal, delta L equals L1 alpha theta, no? Delta L equals L1 alpha theta. Then extension of delta L of brass, B, let's say initial length of both are L, then it is L, alpha is 18 times 10 to the power minus 6, theta is 1, no? Right? So similarly, delta L of iron is same initial length, but 10 times 10 to the power minus 6, temperature difference 1, no? Now, when brass is extended by 18, iron is extended only by 10, which means the rest of the iron should be extended with a stress, right? The rest of the iron should be extended with a stress, right? So therefore, extension of iron is, right? This difference of these two, delta L of brass minus delta L of iron, that is the extension of iron now. Then L is common, then it becomes L is common, 10 to the power minus 6 is common, 18 minus 10. So that is L times 8 times 10 to the power minus 6, right? So this is the extension of, iron wire, right? Stress is asked, right? So we know stress F4A is Y E over L, right? Y was given 30 times 10 to the power 9. Now E is here, maybe E is here. Then L times 8 times 10 to the power minus 6 over initial length L. These two cancels. Right? Now, since this is MCQ, you should check these things. Since this is MCQ, but especially you have to check these things. Only number here is 3. Only number here is 8. 3 times 8 means as a digit we are going to get 24. No? As a digit we are going to get 24. The only answer with 24 is, right? The only answer with 24 is this one. Then it must be first answer. Right? Simplify and see. 2.4. Yeah, it's coming. 10 to the power 5. Right? But without doing any further simplification, we can guess it because only remaining numbers are 3 and 8. Only remaining numbers are 3 and 8. Right? So again, this idea is somewhat important. This idea is somewhat important. When both are thermally expanding, right, the rest should be expanded here with a stress, right? Next, the minimum amount of work that has to be done in order to fix a light elastic string to initial length L naught between two parallel separated distance d greater than L naught. Okay, then initial length of the string has been L naught. Initial length of the string is L naught. Now to fix this, right, a higher length is used. That is d. It says that is d. Then this part of the wire is extended, no? This part of the wire is extended. That is d minus L. So d minus L naught. That is actually the extension of the wire now, right? That is the extension of the wire. Then work is asked. right? Minimum amount of work. What's the equation of work? Work in elasticity is given by half Fv. Work is half Fv. What about the force now? With the tension T is okay. So tension is given T. Then half times T times half times T times extension. Extension is here. That is D minus L naught. Then the final answer, half T D minus L naught. Half T D minus L naught. 4, right? No, not 4. It is half T D minus L naught. 1. Eh? It's 1. Half T D minus L naught. 1. It's 1. Right? It's again a simple one. Just identify the extension. That's it. Right? Just identify the extension. Right now, as a batch, you are 14 weeks from the exam. Right? 14 weeks from the exam. Today is Thursday. So it is exactly 14 weeks and 3 days. Exactly 14 weeks and 3 days. Right? So we are about to start the 13th week on Monday. We are about to start the 13th week on Monday. Right? So that's a very small time period. Work hard without wasting your time. Right? That's a small time period. And the most critical time period you got in your life. Right? So undoubtedly, that's the most critical time period you got in your life. Right? That is going to decide who you are. That is going to define who you are. That's the thing. Right? So be mindful and be careful. Stay on track. 26. The applied force F and extension delta L curve for a metal wire is shown in figure. Consider the following statements. Right? If another wire of lower cross-sectional area is used without changing other parameters, the corresponding curve would fall above the curve in the figure. Right? Now, let's find out how this curve is plotted. Right? So, we know our equation is F over A is Y E over L. Right? Now, in this case, instead of E, delta L is given, then delta L over L. Right? In that case, it's fine, delta L over L. Right? Now, subject F to plot a graph, then F equals, and isolate delta L. F equals Y A over L delta L. See, now this is the graph it has been used to plot this. This is the equation. This is X, and this whole thing is in gradient. This is in Y. Right? To decide whether the graph goes above or below, you have to check the gradient. Right? Higher the gradient, higher the slope. Lower the gradient, lower the slope. Then, right. First one, if another wire of lower cross-sectional area is used without changing other parameters. And one more thing before checking, it says it's for a metal wire, no? It's for a metal wire, which means Y is unchanged. So Y is unchanged, no need to think about Y, argue on Y when you argue on the rest. First one, if another wire of lower cross-sectional area is used without changing other parameters, right? The corresponding curve would fall above the below. No, then because gradient is proportional to A over L, no? Then lower area means lower gradient. Lower area means lower gradient. That is wrong. Lower gradient means that curve goes below. That curve goes below if that's a lower gradient. B, if a wire having identical parameters but with a larger Young's modulus. Yeah, Y is also given. Then let's go here. Large Young's modulus means, again, gradient is going to increase. Because gradient is YA over L. No? Then large Young's modulus means gradient increases. Then it should go above. Then statement says it goes below. That's also wrong. Statement says it's going below. It's also wrong. See, if a longer wire is used without changing the other parameters, the corresponding curve would fall below the curve in the figure if a longer wire is used, right? See, if a long wire is used, L increases. When L increases, M decreases, which means it goes below, right? Would fall below. So this is correct. That's only C. That's only C, right? Statements. Only C, right? Next. 27. Figure shows the variation of the extensions delta L produced by three different metal rods A, B, and C with the force when they are subjected to a tensile force F. If EA, EB, and EC are the corresponding energies stored in the rods due to extension, then, right. So we know these are perspective theory part. We know when we plot a FE curve, right? When we plot a FE curve, see, when we plot a FE curve for with extension, right? So this is the curve. Area with extension axis. Area with extension axis, right? This we have proved. Area with extension axis is given work, right? Work co-energy. So this is work co-energy, right? With extension axis, then simply what you have to do is, what you need to do in the question is find area, find these areas. Then we can get an idea about the magnitudes of them, right? See, first area is 1, 2, 3, 4, 1, 2, 3, 4, 5, 6, no? Then EA means area of A, that is half times 4 times 6, that is 12. So likewise, we have to check the area. Higher the area, higher the work. Lesser the area, lesser the work, right? Then if you do for EB, right, EB, right, EB, 1, 2, 3. Now this delta L axis is given here. That's why I'm considering the area with the delta L axis, right? Always you have to consider with delta L extension. 1, 2, 3, 4, 5, 6. 1, 2, 3, 4. It's also same, no? EB is also half into 6 into 4. That is also 12, right? Then for C, 1, 2, 3, 4, 5, 6, 7, and above it's 1. Then EC equals half 7, 2, ne? Half 7, 2. 1, 2, 3, 4, 5, 6, 7, and this side is 2, yeah. Then these two cancels. It is 7. It is 7. Right? Now compare. EB equals EA and EC is plus. EB equals EA equals EB, EC is less. It's 2. Right? It's 2. Right? Simple as that. Simple as that. Right? Take down. Give me 1 second. Right. Okay. 28. Equivalent Young's modulus. Right? We discussed in the class. I proved this equation in the class. Right? Equivalent Young's modulus. Right? I proved in the class. Equivalent Young's modulus. Right? 28. See, a straight composite rod is made by connecting end to end an n number of rods with identical physical dimensions but having different Young's moduli, y1, y2, y3 up to yn. The equivalent Young's modulus of the composite rod is given by a straight composite rod is made by a straight composite rod, right? Which means now it is made like this by connecting these rods in series combination like this, right? By connecting these ones in a series combination, they are like y1, y2, y3, y4 up to yn, something like this, right? So we know in series combination forces are always equal. In series combination forces are equal. What is different? Extensions are different, right? Extensions are different. Forces are equal in a series combination, but extensions are different. Then let's assume extension of this first one as E1, extension of the second one is E2, third one E3, 4, E4. So likewise it goes up to En, right? Then if total extension of the equivalent is E, if total extension of the equivalent is E, right, then it should be equal to E1 plus E2 plus E3 plus E4 up to En, right? Now expand E, right? We know E is given by FL over YA, right? Because again, F over A equals Y, E over L. So E is given by FL over YA. E is given by FL over YA. E is given by FL over YA, right? Then for this one, for this E, this is same F, but length of the equivalent is NL. If length of one is L, if length of one rod is L, length of the equivalent should be N times L, N times L over YA, Y equivalent CYE A, right? Then similarly, E1, E1 is FL over Y1A, E2 is FL over Y2A, E3 is FL over Y3A. So likewise, it goes up to N, last one, FL over YNA, right? Now, these terms are common, no? F is common, so all F terms cancel each other, right? Area, A cancels each other, right? L also cancels each other, right? Now, see what's remaining here. See what's remaining. From here, only NO YE, right? And from the other side, 1 Y1 plus 1 Y2 plus 1 Y3 plus, this goes up to Yn, goes up to N, it goes up to N, right? We need YE, we need YE, then subject YE, subject YE. Now, answers are not simplified. Then from this term, I'm going to divide this side at once, then N over, right? This should be cross multiplied to this side, cross multiplication to this side. Then over 1 over Y1 plus 1 over Y2 plus 1 over Y3 plus up to Yn. Final answer, N over this thing, right? That's in 4. So answer 4, right? Equivalent Young's modulus. Equivalent Young's modulus. Equivalent Young's modulus. Right? Know the concepts. Know the concepts. Right? We have proved equations also for equivalent Young's modulus. Now here in number of rods are given, so you have to approach the question from scratch. Right? You have to approach the question from scratch. Next. Twenty-nine. The height of a rectangular heavy metal block of mass capital M, area cross section A, area of cross section A, and made of a material of Young's modulus Y, when placed on a horizontal surface as shown in the figure, A is L, right? Okay, figure A is L. If 4 blocks identical to the above mentioned block are stacked together as shown in figure B, the overall height of the 4 blocks will be, right? Overall height. Now, there's no extension in the first one, no? But on the second one, there is an extension. Let's say extension of the second one is E1. Extension means that's a compression actually, right? That's a compression because of the weight. For second one, let's say E2, third one E3, right? There's no extension on the first one. No extension on the first one. There's no weight above. Then if I write for the second one, right? See again, F over A equals Y E over L. So E is given by FL over YA is given by FL over YA. Now, if I apply this for first one, E1, right? The weight on E1 is only 1 mg, no? Weight on E1 is the weight of this one above, only 1 mg, right? Only 1 mg. So, likewise, these weights are there, right? On the second one, there is only 1 mg. There is only 1 mg on second one. Then, this is mg, right? mg L over YA. Now, if you do the same for the second one, on top of second one, right? On top of second and third, ne? E2, that's the third one, right? 1, 2, 3, 4, right? E2 on the third one, on top of the third, there are 2 blocks. On top of the third, there are 2 blocks. Then this becomes 2 mg. 2 mgl OIA. Then we can do the same for E3. On top of the last block, there are 3 blocks, 3 more blocks. Then 3 mg L over YA. Total height is asked, no? If it was not extended, if the system was not extended, total height supposed to be 4L. Now it is extended, it is compressed. Huh? Now the system is compressed, right? Then total height should be, right? So therefore, the height is, right, 4L minus these extensions, E1 plus, E2 plus, E3. Because extensions are the parts compressed. Those are the compressions. Right? A compressor equals 4L minus. Now for E1, E2 and E3, MgLO YA is common, no? Right? So you can take it out. MgLO YA is common. MgLO YA is common. Then 1 plus, 2 plus, 3. Right? L is also taken out in the answers. Then 4 minus L is taken out. Measuring in 6 ne? Minus 6 mg over YA. 6 mg over YA. Right? Fourth one. That is also a good one. Right? A kind of a good question. Right? A kind of a good question. Right? Take down. Right? Take down. Give me 1 minute. Okay, next. 30. 30. Right. 30. A particle of mass m is attached to one end of a light elastic string of force constant k and unstretched length L naught. Unstretched length L naught. The other end of the string is fixed onto a vertical frictionless wall at y equals 0. Right? At y equals 0, a coordinate is given. The particle is then projected vertically downwards from the position y equals 0 with a velocity v naught. V naught is less than, v naught is a good hint, is less than root 2g L naught. Right? What's the idea? We know when an object falls under gravity, for a height h, right, velocity acquired by this object is root 2gh. Right? Now it says this velocity is less than 2gl naught, no? Which means it is not going to reach the point L naught. That is not going to reach the point L naught. Right? So somewhere here it is going to stop the motion. Right? Somewhere here it is going to stop the motion. And the rest of the motion will be stretched, say extension E, and it is going to go up to an instant rest. Right? That's the altered point. Lowest point, that's an instant rest. That's an instant rest. So at this point, right, at this point, this velocity will become 0. right? So it was projected here with V naught. It was projected here with V naught, right? Now we all know there was no energy loss in this thing now. There was no energy loss. If there's no energy loss, with this same energy, it comes up now, right? No energy loss. There's no energy loss. No energy loss. Since there's no energy loss, with this same velocity, it projected downwards, it comes upwards. Same V naught, right? Now, if it comes upwards with same V naught, right? We know it's reaching the rest of the motion under gravity. It's traveling the rest of the motion under gravity, right? It's traveling the rest of the motion under gravity. Then after this point, what it is going to do is, see, after this point, what it is going to do is, it is going to travel this motion under gravity. And this velocity, it's clearly given, this velocity is less than 2gl naught, right? Which means the string is not going to extend by L. So it is going to stay under gravity. It is going to travel under gravity. Since it travels under gravity, then apply an equation like, we need the coordinate now. Then v squared equals u squared plus 2a's applying at here, applying at this level from here to this topmost point. Right? මේ h එක හොයාගත්තා නම් හරිනේ. So that is h. ඒකනේ coordinate එක. h එක හොයාගත්තා නම් that's a coordinate. If you find h, right, that's a coordinate. Then v squared is 0 finally. U squared is v naught squared minus 2g h, right? Then 2gh equals v naught squared. We need h. H is v naught squared over 2g. V naught squared over 2g, that is answer 5, right? So simply the main points I used were, since there's no energy loss, it comes back to point y with the same velocity it is projected, that is v naught. Then with that v naught, it travels under gravity. With that v naught, it travels under gravity, right? With that v naught, it travels under gravity. Something like that. Something like that, right? Next. Next. The height of a vertical uniform rod when one end is firmly fixed to a horizontal surface in air as shown in figure A. As shown in figure A is L. Okay. Then the other end of the rod is kept in vacuum chamber hung from the roof as shown in the figure. Assume that the chamber does not exert any force on the contact point of the rod. Right? Y is the Young's modulus of the material of the rod, and the atmospheric pressure is P naught. P naught is the atmospheric pressure. If L naught is the height of the rod in figure B, then the ratio L to L naught is. Right? Now, this is a vacuum medium. No pressure. This is a vacuum medium. Right? Vacuum means there's no pressure inside. But here, atmospheric pressure acts. At here, atmospheric pressure acts. And because of atmospheric pressure, we know this should be contracted. Because of the atmospheric pressure, this should be contracted. So this is contracted now compared to this. See, this is contracted because of atmospheric pressure. Then initially it was here and finally it's here. Then considering it, we can apply this now. F of A equals y times EOL. Right? F of A equals y times EOL. Right? Then F of A is also written as, can also be written as pressure, no? Then this is pressure P naught, because pressure equals force over area. That is also written as, that can also be written as P naught. Y is given as y, right? Extension. Now E should be L naught minus L, no? L naught minus L. Initial length is L naught, right? Now cross multiply P naught over y equals, we can divide this separately, 1 minus L over L naught. My target is L over L naught. Then switch sides. L over L naught is given by 1 minus P naught over y. Right? 1 minus P naught over y. If you understood the question, it's nothing. But if you didn't get the question, right? Sometimes you might get stuck if you didn't get the question. Right? A pressure part is given also. You have to check how this pressure is connected. You have to check how the pressure is connected. Right? So we have to think, we have to argue. See, that's how the pressure is connected. FOV, FOV, it can also be written as pressure. It can also be written as pressure. Right? Can also be written as pressure. Next, 32. In 32, there's a small mistake in this statement. This should be W1. This should be W1, corrected as W1. This should be corrected as W1. Right? It should be corrected as W1. Right. Let's see, 32. In the experiment, to find Young's modulus, 3 different wires, W1, W2, and W3, of the same material have been used and obtained 3 curves, G1, G2, and G3. Right. Then G1 is W1, W2, and W3. Right. Respectively. For the graph of applied tensile force F with extension delta L, as shown in the figure, which of the following statements made for the reason of obtaining different graphs is true? Right. Okay. See. First one, the wire W1 may have a larger. Check we need what? Gradient. Check the gradient of the graph again. Right? I did the same thing before. F of A equals Y E of L. Right? Now F is subjected. F is YA, E is delta L over L, which means F equals YA over L delta L. Right? Now this is our graph. This is X. This part is gradient. This is Y. Right? So that's how it has been Y equals mx. That's how it has been Y equals mx. Now, gradient of this graph is YA over L. Gradient of this graph is YA over L. Right? Let's see. Gradient of graph is YA over L. First statement. The wire W1 may have a larger length and a smaller area of cross section. Larger length. Larger length means larger the length, lesser the gradient. No? And small area of cross section. Smaller the area, smaller gradient. Smaller gradient means the graph is going to go below. Graph is going to go below. So this one is wrong. Right? Second one. The wire W1 may have the same length as W2, but a smaller area. Smaller area. W1 has a small area. No. If that's a small area, smaller gradient, then it should fall below this one. W1 is the highest gradient. So it cannot be true. It cannot be true. 3. The wire W3 may have the same area of cross section as W1. W3 may have the same area of cross section as W1, but a length than W1. Right? In that case, now we know M equals YA over L. Right? The wire W3 may have a higher length. Oh, if the length of W3 is higher, right? Lesser the gradient, no? Right? Higher the length, lesser the gradient. Higher the length, lesser the gradient. Now W3 is a lesser gradient. It's somewhere here. It's a lesser gradient. So it is an acceptable answer. Right? Let's check 4 and 5 also. Right? 3 is correct. But for the safety, check 4 and 5. The wire W2 may have a small area of cross section, but a larger length than W3. No. If there is a small area, it should fall below W3. No. Wrong. Then 5, the wire W3 may have larger values for the ratio area of cross section over length. Make a ratio again, area of cross section over length. If there is larger, gradient is larger, but W3 is the lowest gradient, so it cannot be true. Answer 3. Answer 3. Right? It's 3. Right? A good statement question. Right? A good statement question. It's 3. Next. 33. When the tension of a wire is slowly increased from T1 to T2 within the proportional limit, its length changes from L1 to L2. Length changes from L1 to L2. Now, graphically, if I try to represent this, F and L, right? So this is what is happening somewhere here. Right? We don't know at which point exactly. but something is happening here. Something is happening here. The force increased from T1 to T2. No? Force increased from T1 to T2. Then length increases from L1 to L2. Length increases from L1 to L2. Right? Now, for energy, we have only one equation. Right? For energy, we have only one equation, that is work co-energy W equals half Fv. Right? Half Fv. Then this is about F. This is only one F we have here. One F. Then if F changes in a range like this, now this is a range T1 to T2. T1 to T2 is a range. If it changes in a range, we have to apply the mean value. We have to apply the mean value, right, for the range. Right? Therefore, mean force equals T1 plus T2 over 2, no? Average value. T1 plus T2 over 2. Right? Then when this extends from here to here, we know exactly this part is the extension. Exactly this part is the extension. Then applying this equation, then W equals, right? Mean area, mean force should be put here. Mean force should be put here, right? And one more thing, if we are using the equation, there's one more thing. Listen. Now, this is not a F delta L curve. See, this is a good point. This is not a force versus extension curve. This is force versus length. Force versus length. Right? This is force versus length. Then if I get this area, if I can get this area here from L1 to L2, when the area from L1 to L2, then we can find this, right? Which means now work is given by force into extension, right? Force into distance or force into extension. Distance, force into distance or displacement. Now the force is the mean value, that is T1 plus T2 over 2, and the length is the extension. Now half is separated, half times T1 plus T2, and the extension is L1 to L2 means L2 minus L1, right? That's it. Half T1 plus T2, L2 minus L1. T1 plus T2, L2 minus L1, it's 5, right? It's 5. That's a little bit tricky and a different one. Not the typical question you get. Not the traditional and the difficult question we get annually. A little bit different. Right? Little bit different. Next. 34. A metal wire of length 2 meters and cross-sectional area 5 square millimeters is rigidly clamped at 2 points A and B, which are 2 meters apart at the same horizontal plane. Then a block of mass 2.4 kilograms is hung from the midpoint of the wire, as shown in the figure. Okay, 2.4 means that is 24 newtons, right? That is 24 newtons. The midpoint of the wire sags 2 centimeters from the initial position, and the total extension of the wire is 0.04 centimeters. Sags 2 centimeters. What will be the approximate value of Young's modulus of metal? Approximate value of Young's modulus. Right. Now, to write an equilibrium, let's consider this angle as alpha. Right. Now, from this triangle, if this angle is alpha, if this is 2 centimeters, right? If this side is 1 meter, 1 meter means 100 centimeters, no? Right? Now, say this tension on the wire is T. So this is also T, no? Right? Now you can write a vertical equilibrium. Vertical upwards we have T cos alpha, that is 2T cos alpha. Downwards 24. Now from this triangle, we can write cos alpha. Cos alpha equals adjacent side. Cos alpha is on our, since it's given as something like this, approximate value is asked. Approximate value is asked. If this is 100, we can approximately consider this also as 100. Approximation, that's an approximation, right? Then this is cos alpha is 2 over 100, no? Right? Which means cos alpha is 2 times 10 to the power minus 2, 2 over 100, 2 over 100, right? Then here 2t cos alpha is 2 over 100, 24, right? See, this cancels. 2 times 2, it's 4. This is 4 times 6, which means T equals 600 newtons. And T again now. T equals 600 newtons. T is known now. T equals 600. T is known. T equals 600. Right? If T is known, now apply in our Young's modulus equation. F of A equals Y times E over L. Right? Now, T is known, F is known, then 600 over area. What was the area? 5 square millimeters, then 5 times 10 to the power minus 6 to convert. Y we need to find Y. Yeah. E is given. E is 0.04 centimeters. 0.04 centimeters. Centimeters into meters. 10 to the power minus 2. Then this is 4 times 10 to the power minus 4 altogether. No? Because this is 4 times 10 to the power minus 2 centimeters. Centimeters to meters is 10 to the power minus 2 again. So 4 times 10 to the power minus 4 altogether over initial length of the wire was 2 meters. Initial length of the wire was 2 meters. Initial length of the wire 2 meters. Right? Simplify now. Simplify. 5 and 60 cancels, no? 12, which means this is 120. 120. Right? And 4 and 12 cancels, it is 3. So that is 30. Right? Then y equals 30 times 2 and it's 60. 60. And when this 10 to the power minus 4 comes to the other side, 10 to the power plus 4. And 10 to the power minus 6 goes up, 10 to the power 6. Right? So that is 6 times 10 to the power 11. That is 6 times 10 to the power 11. 6 times 10 to the power 11, it's here. 6 times 10 to the power 11. Right? Approximation is given. Since that is given as an approximation, I can approximate this value to this. Right? That was a logic we used. Approximation is given. Right? So if that is not given as to approximate, we can't do anything. Right? It is given as to approximate. So then we can approximate. That is given. That is asked us to approximate. So we can approximate. That is asked to. Right, next. 35. Which of the following pairs of physical quantities have the same dimensions? Stress and strain. Stress has dimensions of pressure. Stress has dimensions of pressure. Strain is dimensionless. Right? Work and energy, correct. Work and energy is the answer. Velocity and displacement. Velocity is LT minus 1. Displacement is L. Displacement is L as a dimension. Weight and mass. Wrong. Weight is a force. So that is MLT minus 2. Mass is M. Torque and angular momentum. Torque is a force movement. Right? Then there is ML squared T minus 2. Right? And angular momentum is I omega. Angular momentum is I omega. Right? I omega means dimensions of I is ML squared, omega is T minus 1, that is ML squared T minus 1. The correct answer is 2, work and energy. That is very straightforward. 36. The breaking strain of aluminum rod is 0.02%. Right? Breaking strain is given as a percentage now. Breaking strain is EOL, no? Now EOL is given as a percentage, which means EOL should be 0.2 100, right? Then this value is 2 times 10 to the power minus 3. strain here is 2 times 10 to the minus 3. That's the idea. Strain here is 2 times 10 to the minus 3. Right? What is the minimum cross-sectional area of the rod to withstand the force of 3.5 times 10 to the power 3? Young's modulus of aluminium is, okay, given. Right. Then, F over A, our equation again. Right? We are doing the same thing because we have like 2-3 equations here in electricity. Right? Young's modulus. It was a Young's modulus with temperature difference. Then work. Right? Only 3 equations. F over A equals Y E over L. Right? Force is 3.5 10 to the power 3. We need area. Right? Y. Y is 7 times 10 to the power 10. And this strain is, I found the strain 2 times 10 to the power minus 3. Right? This is going to simplify 3.5 times 2 here. 3.5 times 2 here. Right? Then simplify. This is 10 to the power 3 and this is 10 to the power 10. Then 10 to the power 3 cancels and here only 10 to the power 7 remains. Right? Cross multiply. Then A equals, here we have a 4. Then it comes to this side as 1 over 4. 2 times 2 is 4, no? Right? 10 to the power 7, 10 to the power minus 3 means 10 to the power 4. Then that is 10 to the power minus 4 on the other side. So this is 0.25 10 to the power minus 4, which means 2.5 times 10 to the power minus 5. 2.5 times 10 to the power minus 5. Now, since this is MCQ, right? As soon as you saw a 1 over 4 is created, you can pick the answer. Only 2.5 is given. As soon as you saw 1 over 4 is created, you can pick the answer. 2.5 10 to the power minus 5. Right? 36, 4. Right? And here strain is given as a percentage. So convert that given percentage to the actual value we need. Right? A percentage value is given like this. Then I converted it to the value. Then we can plug it here as EOL. Right? We can plug it here as EOL. Next. The Young's modulus of a material of a wire depends on. Simply, this is the idea. Young's modulus is a constant for a material. Young's modulus of a substance, a material, is constant for the material. Say Young's modulus of this pen is Y, then even if I take half of this pen, it's still Y, right? If I take 1/4 of this pen, still that is Y. Say area of the pen is reduced, still substance is same, no? It's same, Y. So likewise, Young's modulus is something on the substance. That is a property of the substance. Right? Then 37. The initial length of the wire, the Young's modulus of the material of a wire depends on initial length. Wrong, because Y depends on substance. Y depends on substance. Right? Substance means material. Y depends on material, the substance. Right? The cross-sectional area of wire. Wrong, because substance is same. No? The nature of the material of the wire. Nature of the material means that is about the substance. That is about the material. That is correct. Right? So only C. 37, only C. 37, only C. Right? Doesn't mean that is in the equation. And since that is in the equation, just because that is in the equation, Y depends on area and length. No, not the thing. Y is the constant. In the equation, these two changes. No? F of A equals Y E of L. Right? So what's happening is Y is a constant. What's happening in the equation is Y is a constant. Then here the variables are the other four. Stress proportional to strain. This is the variable. Stress proportional to strain. Y is a constant. Y is always a constant. So it's answer 3. Right. That's all. Any questions from what we have discussed here? Right, I think we discussed around 19 questions today, right? 19 MCQs within an hour, within 1 hour and 15 minutes of time, right? Any questions? Anything to clarify? Anything to know before we wind up? Anything to know before we wind up? No questions, all clear? Is it? Right. No questions, right? Okay then. Right. So reminding again, listen. Reminding again, we are just 14 weeks from the exam, right? We are just 14 weeks from the exam. A very small time, it flies, right? Exactly 14 weeks and 3 days. The time is going to fly now. Time is going to fly. And we also will be busy with our subject related things, right? In all 3 subjects, right? Now, from my side also, 2 more seminars are coming on. I mean, practical seminars, 2 more practical seminars. Other than those 2 practical seminars, there will be another like question discussions like S2A or like other types of question discussions and many things. And about your other subjects also, it might be the same. It should be the same, right? So therefore, last days, final days means it's a very hectic, a busy time period for all of us, right? It's a hectic and a busy time period for all of us. So managing time is the key here. Managing time is the key here, right? Manage time accordingly, right? Time management is the magic behind this. Time management. Time management is the magic behind this, right? If you manage time, then you will go through. Right? If you fail to manage time, right, then you will stuck somewhere in between, and after the exam you might regret about yourself without not being able to manage your time, right? So manage your time effectively, and you can break down the work during the week for all 7 days of the week, 3 subjects, right? And manage it accordingly. There's a very small time remaining, right? A very small time remaining, right? Okay, then I'll also continue the SUA sessions from my end on Thursdays or Fridays as I have a free time. Right now, today also I'm doing this after 3 classes straight. Right. So likewise, when I get a time, I can have this. Right. And about the next sessions coming up on S2A, you can get all updates from all the channels. Right. All the channels or Facebook page or YouTube channel, Telegram channel, WhatsApp channel. Through all channels, you can get all the updates, right? So even if you are a regular student or not, doesn't matter, right? Join here and finish this off, right? You can cover the past papers from this end, right? Then from my side also, I can give you that contribution, covering the past papers with these reviews. Then ultimately, you will also cover the past papers without any hassle, sometimes without putting much effort, because you are doing this weekly with me, right? Okay, then if no questions, we can wind up. Then let's wind up, work hard, study hard without wasting time, right? See you in the next class. Good night then. Good night and goodbye.